to this presentation introducing the basic usage of Java Database Connectivity API, or JDBC. JDBC is a General Application Programmer Interface, or API, that allows Java client code to connect to and interact with a database. The API itself is little more than a collection of interfaces that specify how Java client code can interact with a database. Database vendors such as IBM or Oracle publish the actual drivers, which are the implementations of the API that connect to a particular database system. This allows you to write generic JDBC code without having to worry about the details of connecting to a particular database system. If you keep your code abstract, it allows you to switch the underlying database by simply switching out the driver without having to change any of your actual code. The API has a lot of features, but we'll focus on an important subset of these features, including the connection, prepared statement, and result set objects. The API provides support for coercing database columns into common Java types such as integer, double string, and many more. The basic usage pattern of JDBC is a 6-step process. First, you load the JDBC driver from a particular jar file provided by the database vendor. Second, you make a connection to the database. Then you formulate your query or queries and prepare any statements with parameters. Then you execute your query. If you are retrieving data from the database using a select query, then you need to process the results. If you're writing data to the database, then you skip this step. Finally, you need to clean up after yourself by closing any resources and connections to the database. We'll look at each of these steps in detail. The first step is to load the driver for a particular database that you want to connect to. The example code here is connecting to a MySQL database and loads the driver defined in the package com.mysql.jdbc. The driver is loaded through reflection in this example, but can be made configurable at runtime or delegated to the server, for example. We load the driver again because we want our code to be abstract and portable. If we wrote code that was specific to a particular database, then if we wanted to change the database, we would potentially have to rewrite our application. To avoid this, we keep our database interaction code generic by writing towards the API and not toward a particular driver. This allows us to change the underlying database by simply swapping out a different driver. Loading the driver throws 3 checked exceptions which we must catch. We'll discuss the best way to handle this later on. The second step is to make a connection to your database. You'll need 3 things: the URL of the database and a username and password. In this example, I'm connecting to the CSCE server. You would obviously want to change the CSCE login instances to your own login and provide your database password. We then pass these 3 things to the driver manager to get our connection object. Nearly every method in the JDBC API throws a checked SQL exception that must be caught. Again, we'll discuss the best way to handle this later on. By default, all connections are auto-commit. That is, every query you submit to the database through the connection object will automatically be committed once it's submitted. You can change this default using the setAutoCommit method, which takes a boolean. If you shut off autocommit, you will need to manually commit queries to the database using the commit method. This allows you to implicitly handle transactions to the database. After each manual commit, a new transaction is implicitly started. You can also roll back transactions using the rollback method. Some drivers support read-only transactions, which you can set using the setReadOnly method. The next step is to formulate your query by preparing a query statement. There are other ways of submitting queries through JDBC, but we'll only cover the prepared statement object. It really is the only safe way to interact with a database, as we'll cover later. You can write a query and place it in a regular Java string. Within that string, you define any number of parameters using the special question mark character. Unlike arrays, parameters are indexed starting at 1. The parameters are like variables that can be set and reset so that you can use one prepared statement to insert a collection of records, resetting the column values for each query. Parameters are also safe. For example, the prepared statement is responsible for escaping any special characters such as single or double quotes, so that you don't have to. Prepared statements also sanitize SQL, preventing SQL injection attacks, as we'll cover later. Here's an example of inserting a new record into the database. We write our query in a string, then have our connection prepare the statement using this query. The connection object returns a prepared statement object, which can then be used to set parameters. In this example, we've set 2 parameters. The indices start at 1, and their types are strings, so we use the setString method to set the parameter values in each query. If the type were an integer or a floating point number, we would use different methods such as the setInt or setDouble method. We execute this query by invoking the executeUpdate method. This method is used for all writes to the database, including insert, update, and delete queries. The method returns an integer which represents the number of rows that have been affected by the query. Select statements are handled a little differently. We still create a prepared statement and set its parameters the same way, but to retrieve the results, we use the executeQuery method instead. The executeQuery method returns a set of results. That is a collection of rows and columns. In Java, this is represented using a resultSet object. The resultSet is a collection that you can iterate over. Initially, it points just before the first row. You can use the next method to iterate to the next record in the resultSet. The next method returns either true or false depending on whether or not the resultSet currently points to a valid record. That is, once the resultSet iterates through all records, it returns false. This means that you can use it in a while loop pattern to easily iterate over every record. For each record, you can access column values using getter methods and the column name or alias that you queried with. Consider the following example that retrieves the title and numCopies column values for every record in the book table. There are no parameters to set, so once we prepare the statement, we execute the query, which returns a resultSet. We then iterate over the records in the resultSet using a while loop. Within the loop, the resultSet points to the current record. We can retrieve the values using getters and passing the column names as strings. We use the appropriate getter method for the column type. The final step is to clean up after ourselves. The JDBC objects hold on to valuable resources including memory, database connections, etc. Once we are done interacting with the database, we need to release these resources so as not to waste them. All of the objects that we have used must be closed using the close method. If we fail to close the resources, the objects may continue to hold on to connections and memory, potentially impacting the performance of the database and our application. If we fail to close connections, for example, we may eventually run out, preventing our application from accessing the database. Let's take a look at a full demonstration of using JDBC to connect to our book author database. Specifically, I'll show you how to set up a Java project in Eclipse to use JDBC. We'll write methods to retrieve authors and books. I've already started a project and created a few classes, including a class to model authors and books. In both of these classes, I'm keeping track of all of the columns stored in the database, including the primary key, the title, numCopies, and an author. In the author, I've got a primary key, the first name, and the last name. I've already set up constructors and getters and setters as well. I've already set up our three methods that we're going to implement, and created a demo to test them later. Though JDBC is part of the standard Java developer kit, the actual implementation provided by a vendor is not. We'll need to retrieve it from the vendor's website. In this case, we're connecting to a MariaDB instance, which is compatible with MySQL. MySQL is owned by Oracle, so we go to the Oracle website to download the connector. I'll download the latest version. This is the jar that we'll need. We can integrate it into our project by creating a library folder. And we have to make sure to add it to the build path. There are other ways that you could set up a project for JDBC, such as using Maven or some other sophisticated build system, but this is the quickest. Let's now implement this first method. First, I'll need to load the driver. I'm using the multi-catch feature here that was introduced in Java 7, and I'm rethrowing the exception as a runtime exception, an unchecked exception. Now we need to create our connection. Note that there are actually two connection objects. The interface that's part of JDBC, and the actual implementation that was provided by the jar file that we downloaded. Again, we want to program towards the API and not towards a particular implementation. So we need to import the appropriate connection type. Furthermore, this throws a checked SQL exception that we will again rethrow. The URL, the username, and the password are stored as static final strings in a different class. Now we need to formulate our query. For this query, we'll be getting all of the authors. So note that I'm using a different convention here. All of my SQL keywords will be capitalized to make them stand out within a query string. Some IDEs or plugins may provide syntax highlighting for SQL query strings within a string. We also need a prepared statement and a result set. Once we've processed the result set, we need to clean up after ourselves. We need to close the result set, then the prepared statement, then the connection, in the reverse order that we initialized them. We also want to make sure that we are checking for null and checking that they're not already closed. We could have done all 6 steps in one giant try-catch, but separating them out into smaller try-catches allows us to have more fine-grained control. Let's now test this method. It seems to work. We're getting the 7 authors that are in the database. Let's now implement the second method, where we get a book from the database, queried by its ISBN. The loading of a driver and getting a connection are exactly the same. In general, you should avoid such copy pasta. You could put this functionality into a connection factory, or better yet, use a library to do connection pooling. Let's now formulate our query. Here we have a parameter that we need to set. After we prepare the statement, we need to set that parameter. Recall that the ISBN is unique. We should only ever expect this query to return 0 or 1 results. 0 if no record with such an ISBN exists, and 1 record if it does. Therefore, we don't use a while loop. We can use an if statement. We have to be careful. If we immediately return the book object, we will have left the connection, prepared statement, and result set open. We should not immediately return this object. Instead, we should save it off and return it only after we've cleaned up after ourselves. Moreover, what do we do about this author here? From the query, we're only getting the author ID. One solution would be to write another method that retrieved an author object from the database, given an author ID. Another option would be to change this query so that we immediately join to the author table. Let's rewrite the query. Now we can create a new author. This instance of author won't have the author ID. If we needed it or wanted it, we would have to change this code. Let's take care of the situation in which the ISBN might not refer to a valid record. We can throw a new exception here. Now if we ever query for an invalid book record, it'll get thrown back to us as an illegal state exception. Other design choices are possible. We could even add additional code to ensure that our constraints are working properly. Either there's one book record or no book record. But if there's more than one book record with the same ISBN, we could also throw an exception there. To do that, we would just have to check if the result set still has elements in it. Though arguably this type of code should be put into a test suite. Let's go ahead and finish out by closing our resources. Again, we can use the code from before. Again, let's test our code. This ISBN corresponds to Good Omens by Terry Pratchett, and there is one copy in the database. Let's now finish out this demonstration by completing the third method. This is similar to the first method in that we're going to retrieve all book records. But note that we already have a method to retrieve an entire book record, including its author, when retrieved by the ISBN. Maybe we can find a way to reuse it. First, again, we do our boilerplate loading of the driver and getting the connection. This simple query will select all the ISBN records from the book table. Once we have the ISBN, we can reuse the functionality in our second method to retrieve the entire book record. We still need to close our resources here. Observe that this is good code reuse, but you should be careful about your resources. Each iteration of this while loop is going to open up a new connection, a new prepared statement, and a new result set. This method closes everything, but we still open up multiple resources. It may be more efficient to rethink this and actually select out all the books at once. For now though, let's go ahead and leave it as it is and see if it works. All of the book records have been successfully retrieved. As we've seen, most methods in the JDBC API throw an SQL exception. This is a checked exception and therefore must be explicitly caught or rethrown. This is a real annoyance and frankly a bit of a design flaw. Checked exceptions were intended to be only for errors that a program could reasonably recover from. However, there is no reasonable way to recover from a poorly written SQL statement, or a misconfigured server, or a missing network connection. Since there is little that can be done, the best thing to do is simply log the error and rethrow it as an unchecked exception. The best way to log the error is to use a logging system such as Log4j, which we will not cover here. In this example, I've logged the error and rethrown it as a generic runtime exception. To reiterate, it's best practice to only ever use prepared statements. In fact, I didn't even cover the other ways of executing queries because not using prepared statements is extremely dangerous. In particular, prepared statements protect you against what are known as injection attacks. They're also more efficient when using batch queries, and using a single method of interacting with the database leads to more consistency and is less prone to errors. To illustrate what we mean by an injection attack, consider the following scenario. Suppose we pull a string value from a web form and store it in a variable named lastName. Now suppose that we use regular string concatenation instead of a parameterized prepared statement. Without sanitizing the input, suppose that a user enters the following into our web form. Then when we concatenate, the actual query that gets run looks something like the following. That is, it runs two queries, the second one being to drop our table. Without sanitizing the input and escaping the single quote, we've allowed an unauthorized user to execute or inject arbitrary SQL code into our application. If the server is poorly configured to allow this, then we'll have lost our data or even worse. SQL injection attacks remain the #1 avenue of attacks against websites. Not using a prepared statement is an inexcusable rookie mistake. If you fail to do so, you really deserve what you get. Finally, when using JDBC, you should generally avoid using the wildcard in the select statements. When using SQL, this is a convenience, but in an application, such a query will retrieve every column even if you don't intend to use them. This means that you're transmitting data over a network that you ultimately ignore. Write your queries to only retrieve the columns that you intend to use so you don't waste network resources. It's always better to write code that is intentional. There are additional issues that we won't cover in depth in this introduction. For example, we stored our database password in plain old Java strings, which is obviously insecure. If we checked our code into a public repo or included it in an application that anyone could easily decompile, they would have access to our database credentials. In practice, it's better to configure your application server to store the password or to set up a secured data source. In any case, more sophisticated security policies and measures, such as firewalling your database server, are also necessary. There are also some efficiency issues. Remember, always close your resources. In practice, it's better to use more sophisticated mechanisms such as connection pools. One of the most costly parts of a database connection is the initial handshake between the client and the server. To improve this, a server or application may open up a collection of connections and keep them open. Then when a connection is needed, it is checked out from the pool of connections instead of opening up a new one. Instead of closing connections, they are returned to the pool to be reused. Usually you can use a library or built-in server functionality to achieve this. You should also be sure to optimize and normalize your database to ensure that your JDBC code is also efficient. Many more topics and resources are available on the website.